All right, we are at the last part of the lecture on Chapter 9 here in our industrial materials class. This is also probably the one area where I think will benefit most everybody in the program and is something that I think all of us need to be aware of. And that's no matter whether we're in the machining part of the program, the welding part of the program, the maintenance side, or the process control side. Of our engineering technology degrees here, we all have to take a look at ways to control corrosion in the course of our job. So first, we're going to talk about corrosion a little bit, and then we'll kind of go into the ways that you as a machinist would need to pay attention to control that corrosion. If you're on the maintenance side, how you can, what the steps are that you would need to take to control corrosion. The same thing from the welding side as well. So we all know that steel rust, that's not a big deal. It forms iron oxide, Fe2O3, in outdoor air. So, and of course, depending on the humidity and the moisture content of the air, that it will can basically make the corrosion process occur faster. When we get these type of iron oxides, oftentimes they will start to flake off, and you've all probably seen an old rusty beater car that you've had and you've gotten underneath, and like the mufflers are starting to wear out, and you see how that metal from the muffler is basically flaking off, and that's iron oxide flakes that are coming off. Now, if the internal components is still thick enough, in the case of a muffler, that's pretty thin metal to begin with, so usually that flakes off and breaks through. But in heavier, thicker irons where that happens, and you get that flaking, you also will start to see pits form there as well. So we do have three ways that we can help to reduce corrosion in steel. The first way, we can protect it with coating. So we'll talk about some of the different coatings. We can connect electrical components or electrically charged components to more electronegative type metals, and we talk about that. That's what we refer to as galvanic corrosion, where we're really trying to control which components will actually rust first and fail first. So, and then there's also the idea of a process here to control that process to be less susceptible. Now, I was a little cautious. I wasn't exactly 100% sure what the textbook was talking about when they said this, but if you remember about the overall processes that we follow when we're talking about corrosion and actually making this steel, oftentimes uh, if we are welding, some of the things that we're doing can introduce different types of bad material, so to say, to the mix that could kind of cause corrosion to happen prematurely as well. As an example, a lot of your stainless steels have a high amount of chromium in it. Oftentimes, in the processing of stainless steels, there's a mixture between the chromium and the carbon that basically adds a little bit more carbon content to that material. And of course, the addition of carbon is also going to help to instigate more rust in some ways as well. So when they're talking about process being less susceptible, they're really talking about maintaining and controlling some of those process changes that can occur to cause corrosion as well. Here's a couple of ideas here. This just kind of showing you, again, getting into the metal coatings. So we've got two issues: a passive coating that just protects steel from shielding it from air, and then we've got a protective coating that actually protects this when the steel becomes exposed as well. So this kind of shows you a process in a plant. Let me kind of move up here so you can get a better see. We're bringing these rolls in, they're cleaning and pickling it. The rolls, then we are applying some type of a tin plate to it. So there's other chemical treatments. Then they are oiling that. So a lot of times oils or rust inhibitors are also added to the material to help keep it from rusting and prevent moisture from getting onto and contaminating that steel as well. And then it comes back in and is taken back up and recoiled. So that gives you an idea of the whole coils that and some of the ways that this is done in terms of tin plating. And tin plating is one of those type of protective coatings. So now, tin plate is what we refer to as a passive protection. So if it's scratched, the exposed steel underneath will and can corrode. So you have to be aware of that. Tin plating is used often in food packaging. So if you sit there and you think about and hear about the term of the old tin can or kicking the old tin can, that's of course where it's comes in play. We do still use steel and tin cans in there, so we'll talk about some other coatings that would be part of the food packaging industry. So we talk about zinc coating or galvanizing. So where they're using zinc, this is an active protection. So that zinc actually penetrates and goes a little bit deeper. So if you do get some light scratches on it, it's not going to be as susceptible to rust as your tin coating would be. So that's kind of an example there of that. Some other types of coatings that we talk about, anodizing is a type of coating. So there's another process called black oxide. So that's done. All of those are more in terms of, if you think about it, actually, let's kind of go back for just a second here. Let me pull this back. So I'm going a little too fast. Sorry. Let's get back into this passive protection. A couple of other types of passive protection coatings are things such as anodizing. That typically happens on aluminum, so where it's kind of a colored type coating that helps to protect that. We also have black oxiding with different types of steel parts, oftentimes in the machine tool industry, on your tool holders and your clamps and other types of components are black oxided. That's just a passive type protection to help protect against rust there as well. It's a form of rust inhibitor there too. We can also talk about chrome plating. So obviously the big one widely used in the automotive industry. Of course, if you think about the 1950s, everything was chrome plated there, and especially all of our appliances. There's been a trend and a resurgence to go back into either stainless steel or chrome plated type of appliances there, just because of the luster and polish and shine for the aesthetic looks of chrome plated items. But that also provides protection there and is a rust inhibitor to kind of keep corrosion from occurring as well. So make sure that you are paying attention to those different types of coatings that go onto it. Now, again, cadmium and chromium both. So if you think about it, these are basically very, very toxic to us as humans. So be aware of the dangers if you're working around cadmium or chromium of what those dangers are. Same thing with carbide. So if you're grinding carbide, you want to take precautions and be aware of the dangers that come about with exposure to those, especially in terms of inhalation issues. All right, we also have organic coatings too. Now, if you think about these organic coatings, most of your cans, if you're talking about your green bean cans and your different types of vegetable cans, oftentimes the interior of those are coated so that there is no metallic reaction with the food. That helps to protect the flavor of the food and helps keep the food fresher as well. So obviously we're talking about different types of fruits and vegetables, certain fruits that are more acidic. If you think about your tomatoes or pineapples, there's going to be a different type of coating in those cans to protect it from the acidic nature of the vegetable as opposed to what might be going into a can that's holding your chili beans. So you have that. And of course, our beverage containers, if you think about your aluminum cans, most of those have a lining in them as well. Again, those are all placed to help prevent the interaction between the acids and the bases that are in the actual soda and the can lining itself, and to protect the flavor and the carbonation there too. So we do get all of these different types of organic coatings in there. We talked about galvanic corrosion before, so we will do a little bit of a lab on galvanic corrosion there as well, so you can kind of see and understand how we can use this idea of different reactive metals that are more reactive than others to basically become sacrificial parts. That way, and especially this in terms of washers, we want the washers to fail first before a bolt. That way we can maybe even see it and replace that before we have a catastrophic failure. So there is also a use here that comes in that's very, very important. Now, maintenance guys and gals, you are going to need to be much, much more familiar with galvanic corrosion and selection of bolts and washers and other types of fasteners because you may unintentionally, if you're not aware of this, you may unintentionally cause things to rust and corrode prematurely as well. So we want to pay attention to that as we go through here. I'll let you go ahead and read that. We'll talk more about galvanic corrosion in that lab here. So we change process variables that provide us with more corrosion resistance. So that's through either composition change or the microstructure change. Of course, when we are welding different types of materials, we're paying attention to that as well, and the possibilities of byproducts that could occur that would also make objects rust or corrode faster in that place as well. Now, all of this, of course, as we talk about it, we still want to maintain what we refer to as sustainable metallurgy. I believe that most companies are doing their part to try to consider their waste of how they are controlling or using the reduce, reuse, recyclable aspects of sustainable metallurgy. Just as a example, I mentioned before my prior work in the canning industry. The can manufacturing company that I used, of course, Crown Cork and Seal, they would have a lot of sheet metal that would be ran through when they were making bottle caps. And of course, the bottle cap process was kind of a coining where the sheet was being fed through, and you're getting the little circular indentations that were kind of being pressed through and more or less coined out of that sheet, which would leave a bunch of sheets of aluminum with all these holes in it. So, well, the engineering staff at Crown Cork and Seal, and this was many, many years ago, realized that they could turn that scrap and sell that to the air filter manufacturers. If you think about the air filters on your furnace, a lot of times there's a thin piece of metal with a bunch of holes in it, and then it's got the filter media wrapped around that. So what Crown often did as a way to reduce, reuse, and recycle was they would sell their scrap to other manufacturers. In this case, the manufacturers were the air filter manufacturers who would use that and their processing material to make air filters. So there are lots of potential ways, and I like to think that a lot of companies out there are trying to be environmentally useful to try to think about what the impact of their processes and their procedures are on our environment and sustaining a much, much more livable future for all of us as we go forward. But and I think we all have kind of a role and a responsibility to try to reduce, reuse, and recycle as much as we can, both while we're at home and while we're on the job.